Day 474 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1277, count square submatrices with all ones. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given the n by n matrix of ones and zeros, return how many square submatrices have all ones. All right, y'all, so that sounds pretty simple, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example one, we have our input matrix grid equals a 2D array of integers, or n by n matrix grid, right, with it being 0, 1, 1, 1, 1, 1, 1, 1, and 0, 1, 1, 1. Those are the different, each one of these arrays represents a different row in the grid. They set it up for us so we don't have to imagine it for us. So this is the grid that we're working with right here, and we want to see how many square submatrices that we could find that have all ones. So the output is 15. Explanation says there are 10 squares of side 1. So there are 10 squares where it's just 1 1, right? So this counts as a submatrix that's 1. This would be 2. This would be 3. This would be 4. This counts as 5, 6, 7, 8, 9, and 10. So boom, we have 10 squared submatrices of side 1, meaning it has one side. The length of the side is 1, or the length of the height is 1, right? Which is just 1, 1. Then we have four squares of side 2, or where the length is 2 or the width is 2, right? So this one and this one, right? Imagine these two put together. This right here is a square right here, right? Boom. These 4 ones right here, that forms a square. That's 1. But then we could do it on this side too. So this forms a square as well. These 4 ones right here, that's another square of side 2. So that's 2 right there. Then we come down, we have a third one right here. Boom, that's the third one. And then the fourth one is right here. Boom. So I can't really show y'all. I can't highlight the whole square, but just say this is the top of the square. This is the bottom of a square. That's one square. Then the second square, this is the top of the square. This is the bottom of the square. That's the second square. Then we come over here. This is the top of the square. This is the bottom of the square. That's the third square. And then right here, this is the top of the square. And this is the bottom of the square. That's a 4. Then we have one square of side 3, meaning there's 3 on each side, right? There's 3 ones on each side. So this right here would be one whole square. Boom, this would be the bottom, this would be the middle, this would be the top of the square. Sorry, y'all, this would be the top of the square, and this whole square right here has a size, or has each side has 3, right? So there's only one square where each side has 3, and that's this square right here. Boom. So all together, when we add those all together, 10 plus 4 plus 1, that gives us 15. So in total, there are 15 square submatrices that we have found. So we return 15 from this input matrix. So let's take a look at example 2. Example 2 has a little bit less squares, but let's go through it just to make sure that we completely understand what's going on. So in example 2, we have our input matrix equals our 2D array of integers. This being the first row, 1, 0, 1. Second row being 1, 1, 0. Third row being 1, 1, 0. The output is 7. It says there are 6 squares of side 1, meaning we're just counting the ones because that is, each one counts as its own square. So that's a square, 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 and that's a square. So that's 6 right there, with where there's only the length is only 1 on each side. Then there's one square where the length is 2 on each side, right? So that's this square right here, where this is the top and this is the bottom, right? This whole square right here has a length of 2 on each side, right? And there's only one square with a length of 2 on each side. So And those are the only squares, so we do 6 plus 1, which gives us 7 squares in total. All right, y'all. So now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult, so let's get into it. First thing we're going to do is we're going to get the number of rows in the matrix by saying let n equal matrix.count, and that's going to get us the number of rows. Then to get the number of columns, to get the number of columns, we're going to say let m equal matrix square bracket 0 dot count, and that is going to get us the columns. Boom. Or the number of columns in the matrix. Then we're going to use some dynamic programming, which will store the size of the largest square submatrix that ends at cell I and J. So, for example, if the dynamic programming array I and J equals 3, that means there's a 3 by 3 square ending at I and J. So we're going to create that dynamic programming array by saying var dp equals an array, open up the parentheses, it's going to be repeating colon, it's going to be a 2D array, so it's going to be repeating arrays, open up the parentheses, excuse me, then we're going to say repeating colon 0 comma count colon m, then we're going to come outside this array right here, but still inside the initial array, and we're going to say this is going to have a count colon n, just like that. Now we need the variable that's going to store our final count of all the square submatrices, so we could just come right here, declare variable, and we could call it count, and let's just call it ands, so it doesn't get confusing, because that's where our answer will be stored. And we can set that equal to 0 just to start. So this is going to store our output, or the number of square submatrices that we have found. Now we're going to initialize the first column by saying for I in 0 dot dot up to n. We're going to open up the brackets, and we're going to say dp square bracket I, come outside the square bracket and say square bracket 0. We're going to set that equal to matrix square bracket I square bracket 0. Boom. Then we are going to, so if the cell has a 1, it's going to form a 1 by 1 square, and then we're going to add to the total count by coming right here, and we're going to say ands plus equals dp square bracket I square bracket 0, just like that. Now we're going to initialize the first row, come underneath that for this for loop, start another for loop, and we're going to say for j in 1 dot dot less than sign m. We're going to open up the brackets, and we're going to say dp square bracket 0 square bracket I, and we're going to set that equal to matrix square bracket 0 square bracket I, and that is the same logic as above for the first row. So if a cell has a 1, it forms a 1 by 1 square, and then we're going to add that to the total count by coming right here, saying ands plus equals dp square bracket I square bracket 0. Boom. Or excuse me, not 0. Sorry, back up. dp square bracket 0. Then we're going to say square bracket j, because we're dealing with j in this one. Boom. So then we have to process the rest of the matrix. So come underneath this for loop, and we are going to say for I in 1 dot dot less than n, so 1 up to n. Then we're going to say for j in 1 dot dot less than m. Then we're going to open up the brackets, and we're going to say if matrix square bracket I, come outside of that square bracket j equals 1. So if the current cell is 1, the size of the square ending at ij depends on its left top and top left neighbors. So we're going to take the minimum among them and add 1. So we're going to come right here, and we're going to say dp square bracket I square bracket j. We're going to set that equal to 1 plus the minimum. So min, 1 plus min, open up the parentheses, dp square bracket I square bracket j minus 1. Come outside the j minus 1 square bracket, and we're going to say comma dp square bracket I minus 1. Sorry, y'all. I minus 1. Come outside the I minus 1 square bracket. We'll say square bracket j. Come outside of that, we're going to say comma. Then we're going to say dp square bracket I minus 1. Come outside of that, and we're going to say square bracket j minus 1. Just like that. Now we need to add the number of squares ending at this cell to the total. So come underneath this if, and we are going to say ands plus equals dp square bracket I square bracket j. Boom. Now we just need to return the total number of square submatrices filled with ones that we have found thus far by coming right here. And we can say return ands. And that should be all she wrote, y'all. Let's give it a run before we submit it. Excuse me, y'all. Okay, we have an error. Cannot find I in scope. Oh, sorry, y'all. Yeah, this should be J. Sorry about that, y'all. J. Boom. Let's run it again. See if that does the trick. And it's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. Oh, look at that, y'all. 10 milliseconds beats 17.39% of users. We could definitely get those numbers up, but for now, I think this is a good solution that's easy to understand, that we can all learn from, which is important because if we don't learn from this solution, then we won't be able to apply anything to the next solution. So that's why it's important to pick solutions that's easy to understand. I think this is a good one for that. So we'll worry about getting those numbers up further down our LeetCode journey. But for now, y'all, make sure you get one more look at the code. This is the top part, and this is the bottom part. And yeah, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.